Hello everyone, my name is Stefan Jessen and I'm the Chief Technology Officer of First Water in Iceland. When you go into a web browser and you search for First Water, you will find out that First Water was once used as a grating for diamonds and other precious gemstones, but we're not into diamonds like you present. Maybe in the future, I don't know. So First Water is a land-based salmon farming company, designing, constructing and operating a large-scale land-based fish farm for Atlantic salmon in Thorlákshöfn, Iceland. The company was founded in 2017 by a group of passionate entrepreneurs. After a couple of years, the company had acquired all necessary permits and acquired the land, bought a hatchery, and was ready to construct in 2021. The first fish came into the station 2022, and currently today, our annual production capacity is 5,000 tons head-on gutted salmon. But when fully built, we target for 60,000 tons annually. The picture you can see here in the background is a very recent aerial photograph of the facility. We have 20 tanks in operation today. 12 of these tanks are open, and 8 of these tanks have roofs. This really shows how a startup company begins with 4 tanks and then it gets bigger and more expensive and more complex. Here you can see a 3D rendering of this facility when fully built. And in the background, there's the nearest town with population of about 3,000 people. The picture you saw earlier was of the small part there with the open tanks. So you can see that we have just started. Even though the process itself is quite simple, the fish needs fresh seawater, oxygen, light, and to live and grow, the facility requires a large and complex infrastructure. If you take the fish out of the equation, this is just pipes and pumps, basically. The total area of the plot is 530,000 square meters, which is about 3 times larger than Legoland in Denmark. The project is divided into 6 construction phases, each with an annual production capacity of 10,000 tons. The first phase will be completed this year, but we estimate that we can finish the whole project in 2031. During this time, we also plan to build a hatchery, a new processing plant, maybe a biogas plant. And you can see here that on the south side of this picture is the boreholes where we source all the seawater. And we have 164 tanks, a hatchery, processing plant, and a lot of other infrastructure. The total amount of water that is in all the tanks is about 550,000 cubic meters, and we replace that water every hour. So you can imagine that you need a lot of infrastructure and pumps. I also want to mention that this is one of the largest projects in Iceland history and is by far the largest private equity-funded project. As I mentioned earlier, the facility requires a large and complex infrastructure. Just like any city, it requires water, heat, electricity, telecommunication, wastewater treatment, but it also requires generation and distribution of oxygen, also piping system for transporting live fish, generators, and all that. Even though the plot is large, every space available is used. All the pipes in the ground are laid in different levels. And the largest pipe you can see here in the picture has the diameter of 2.5 meters and will be used to transport seawater to one of the 6 construction phases, or 8,000 liters per second. The total amount of seawater that we require for the whole project is about 48,000 liters per second. And there's a large amount of equipment and devices in a facility like this, like 1,500 pumps and fans, 1,000 variable frequency drives, and thousands of sensors, control valves, controllable fish lights, and circuit breakers for different voltage levels from 230 to 66 kilowatts, transformers, diesel generators, and PLCs. Today, we estimate that the amount of hardwired I/Os in the facility will be somewhere between 40 and 50,000, and 10,000 Ethernet-connected devices. So in total, the amount of signals will be probably about 150,000. And all this equipment has to be monitored and or controlled to ensure that the system is functioning as intended, and most importantly, to keep the fish alive and happy. I joined First Water in 2022, and at that time we only had a couple of tanks in operation. We had quite a basic control system with a HMI and just a one tablet with a TeamViewer connection to the system. This was only considered as a temporary solution until we would have a full-blown SCADA system up and running. At that time, there were only few employees and not many that had any previous experience with fish farming. Most of us had previously worked on power plants, power distribution, aluminum reduction refineries and utilities. Just like me, I'm an electrical engineer and I don't even like fish. And when we started developing the SCADA system, we based the design around previous experience and emphasized on having everything in the same system, have a multi-screen setup, and to have a good overview for the operators, just like we would expect in a power plant or in a utility company. We decided right from the start that we would use AVEVA System Platform because it's an interoperable platform and highly customizable. It might also have played a role that I've been working with InTouch for 20 years. But we launched the first version of the SCADA system in 2023 with 2 OME clients on a stationary PC. The intention was to get input from the operators and other staff just to see if they would like it early in the process. However, we received very little information from site, so we just kept on developing and added more subsystems and more functionality. But about a year later, when we added more clients, we discovered that the operators had actually never ever used the system. They were still relying on one tablet. So at that point, we realized that we had overlooked an important fact. None of the operators had ever seen a SCADA system before. And our development approach was to base everything on our previous experience, like from the power industry, which is one of the most conservative industry in Iceland, where everything is very customized in the SCADA system and everything is made to look exactly the same for the operators as they are used to it. But I said, our operators had never seen a SCADA system, so we were forcing them to get something that they didn't even know. So once we realized that the operators were not using the system at all, it became clear that continuing this path would not solve any problems. Instead, we decided to stop, take a step back, and design everything from scratch. The first step was to understand the people working in the facility and the task they perform every day. Different teams interact with the system in a different way, and their needs for a control system are not the same. By looking closely to the workflows of operators, technical teams, and other staff, we began to identify the information they actually needed, how they access it, and what tools they would need to make their job easier. After defining these needs, then we could start designing a SCADA system that truly supports the operation of the facility. I'll give you an example. This is a 3D model of 8 tanks. You can see this is a very complex infrastructure. Each building houses 8 tanks and divided into 2 sections. The top section is the operational section. There we have 1 to 2 designated employees which take care of the fish. And on the sub-levels we have all the technical systems. And these two zones are isolated biologically so that the service team is not supposed to go upstairs and vice versa. These operators are solely responsible for these 8 tanks that are within their assigned building. As a result, they only need to monitor and control these 8 tanks that are under their responsibility, not other parts of the farm. We also have a dedicated mechanical electrical team that will work on the lower floor. And the 2 teams, they have separate responsibilities and have different needs for details when it comes to alarms and measurements. The operator, for example, he gets to know that a pump has malfunctioned, but he doesn't really have to know why. That's why we have a technical team. In the operational section, there is a control center with an OMI client on a stationary PC. There you can have comprehensive information about everything in the system or for these 8 tanks. Most of the tasks are carried out in the field. The longest distance within a zone is 150 meters, so the operators, they have a tablet everywhere they go. The tablets only give them the most important information, so they can use the tablets as efficient as possible. The service team also has a tablet, but it gives more information so they can troubleshoot and rectify any problems. Based on my experience, this, however, would not be accepted in a power plant. If you would ever say, hey, let's put up a tablet, they will just, no way. Everyone remembers Stuxnet in 2008, so they want to have it old-fashioned. So the service team, they get an alarm on their phone that something has gone wrong, so they go into the facility, grab a tablet, and then they can go and work. For this environment with many different type of groups, the Intus OMI has proven to be very useful because it's very simple to create different views for different people with different information. The reliability of the system is of the essence. We will have multiple pairs of application and historian servers. When fully built, we estimate that we'll have about 300 employees in 30 different buildings and have 100 concurrent clients using the SCADA system. When we are identifying the needs of different groups, we understood that for most of the office people, I call them office people, they don't really need an access to the SCADA system. What they need is mostly access to data. So for the office people, we will install a tier 2 historian on the office network so we can give all the office people access to the data. And we will also synchronize some of the values to AVEVA Connect, allowing people to access and work with the data they need. We also have future plans. As I said before, we want to implement AVEVA Connect. We also think about moving to OMI web client for all the tablets. Today we only use AVEVA the Access Anywhere. And we have a large amount of cameras around that we want to implement into OMI. I think we will have between 2,000 and 3,000 cameras. And in about 3 years, then we estimate that we have completed administration building where we'll have a large control center where you can monitor everything in the facility. Because in maybe 2 years, we will be taking a new tank into operation every week. So the system becomes more and more complex. We'll have more and more teams. So we would, for example, have to control all the shared infrastructure like electrical distribution and water distribution from one place. So this center will come on top of the other system. We will keep on relying heavily on tablets. But the funny thing is that the SCADA system we designed in the beginning will be the last one that we add to the system. So I think this is quite common that when you go into a new industry, you take your old experience from another industry and try to make exactly the same. But you have to be aware that you might come to realize that the users, this system doesn't suit them at all. So you have to be open for stopping everything and start from scratch and embrace all the new stuff and technology. Thank you.